In the 1940s, the Humber Estuary lost its last oyster. 300 acres of living reef, larger than Central Park, became mud. The water darkened, and flounder and sea bass disappeared. But in July 2025, 48 volunteers waded knee-deep into that same mud and began hand-placing mesh bags on the seabed, each one packed with living oysters, 300,000 of them over the course of a few months. And what these animals did to the water, the sediment, and every species that followed them back into the estuary caused scientists to reconsider everything they thought they knew about how a dead estuary comes back to life. But here is what is truly strange. The company behind it all was the last one anyone would have named. Ørsted, a Danish corporation, the world's largest developer of offshore wind farms. In the United Kingdom alone, 5.6 gigawatts of installed capacity, and it was this private company that wanted to return a living oyster reef to an estuary that had been receiving industrial runoff from 20% of England's entire land surface for decades. Water officially classified as being in unfavorable condition, and the company that drills into the seabed for a living decided that this was where it would prove the opposite. But here's the strangest part. Until 2017, it was called Dong Energy, Danish oil and natural gas. In 2009, it was responsible for a third of all carbon dioxide emissions in Denmark. Then management reconsidered its strategy, placed its bet on offshore wind, and by 2019 had hit its climate target 21 years ahead of schedule. The company sold off its oil and gas business and renamed itself after Hans Christian Ørsted, the Danish physicist who discovered electromagnetism. But there is a problem. Ørsted builds in water. Its foundations drill into the seabed. Its cables cross fish migration routes. WWF wrote plainly in 2022 that the expansion of offshore wind energy risks harming biodiversity if done wrong. Ørsted knows this, and its answer is a stated target. From 2030 onward, all new company projects must deliver a net positive impact on biodiversity. Wilder Humber is their first major test. But why the Humber specifically? To understand that, you need to know what was once here. Olsen's Fisheries Atlas of 1883 shows a continuous oyster reef lying across the estuary floor. 300 acres, a larger area than the entirety of Central Park in New York. A single oyster filters more than 200 liters of water per day. 300 acres of reef is a filtration plant that regenerates itself and feeds 200 species of organisms around it. By the 1940s, not a single living oyster remained in the Humber. Industrial harvesting, sewage, and agricultural runoff were major pressures, and the parasite Bonamia austriae, introduced from France in 1982, destroys the oyster's immune system from the inside. According to the Native Oyster Network, the population of the European flat oyster had declined by 95% from its 19th century levels across Britain. In 2012, Natural England officially downgraded the estuary to unfavorable condition, bureaucratic language that means this no longer functions as an ecosystem. The Humber is simultaneously one of the most protected and one of the most polluted places in Britain. It holds 4 international conservation designations: Site of Special Scientific Interest, Special Area of Conservation, Special Protection Area, and Ramsar Site, the last category meaning Wetlands of International Importance. More than 187,000 wading birds stop here during migration. 9 bird species have populations of international significance here. And at the same time, there are 40,000 vessel movements per year, and the Humber is the largest port complex in the United Kingdom, handling 14% of the country's entire international trade. Chemical plants, oil refineries, and power stations are concentrated mostly on the southern bank. The estuary drains 20% of England's entire surface area. Everything that enters the Trent and the Ouse ends up here. This is a place where nature and industry have existed side by side for 200 years, and that is precisely why it became the test site, not despite its complexity, but because of it. That is why the Humber, Ørsted's British operational hub, sits in Grimsby, right on the banks of this estuary. Walk out of the office, go down to the shore, and you see that same water. They are not saving someone else's river. In 2022, Ørsted Yorkshire Wildlife Trust and Lincolnshire Wildlife Trust launched Wilder Humber, a 5-year program with a budget of £2.5 million. The goal is to restore 40 hectares of marine habitats, seagrass, salt marsh, and 500,000 oysters. But here a question arises that had stopped every previous British project in its tracks. Oysters are a species that needs density in order to reproduce. A female does not broadcast her eggs into open water. She responds to chemical signals from her neighbors. No neighbors means no fertilization. That is why British projects from the late 1990s that began with a few thousand individuals ended in nothing. 30% survival, then zero, then closure. A telling example is a project in the Solent in 2018. The Blue Marine Foundation released several thousand oysters into a protected zone near Portsmouth. The scientific team was serious, the methodology carefully considered. After 1 year, the oysters were alive, growing, looking healthy. After 2 years, the first signs of reproduction. After 3 years, the population began to decline. Density had fallen below the threshold, and the natural reproductive process had not triggered at the required scale. The project did not fail entirely, but it never reached a self-sustaining population. That is the wall against which every British project has broken. Not lack of will, not lack of funding, not poor science. A purely mathematical problem. For a population to reproduce itself, a certain density is required from day one, and to achieve that density requires thousands of oysters simultaneously in one place. And to have thousands of oysters simultaneously, you need a method that did not exist before rapid reefs. Wilder Humber solved this problem differently. Owain Wynne-Jones, commercial director of the Oyster Restoration Company, almost always in wet shoes, spent 3 years convincing conservation organizations to abandon the old model. His company proposed rapid reefs. Larvae are grown in a hatchery in Scotland, settle onto scallop shells in a controlled environment, and enter the water already in the form of a ready-made reef block inside a biodegradable mesh bag. You place the bag on the seabed, and the reef is formed immediately. Here's what happens inside the bag. Ostrea edulis larvae in the hatchery reach the stage at which they are ready to settle, to attach to a hard surface and transform into a juvenile mollusk. In nature, they seek hard ground, ideally already occupied by other oysters, through the very same chemical signal. In the hatchery, they are given scallop shells. The larvae settle, attach, and begin to grow. Within a few weeks, there are dozens of living mollusks on a single shell, packed tightly together. The shells with their mollusks are placed into a biodegradable mesh bag and shipped to the Humber. When the bag is laid on the seabed, the distance between individuals already corresponds to the density required for future reproduction. In other words, the density problem is solved before the oyster ever enters the water. That is why this is called a launch platform rather than scatter and wait. The first release took place in July 2025. 28,000 adult oysters were placed on the mudflats of Spurn Point, the first time in 80 years. Then in December 2025, another 250,000 juveniles in the Rapid Reef system were released, a total of 300,000. A record for the intertidal zone of the United Kingdom. 48 volunteers, more than 340 hours on the cold, muddy shores of Yorkshire. Among them, local residents from Grimsby and Hull, marine biology students from the University of Hull, members of Yorkshire Wildlife Trust, and simply people who saw an announcement and turned up. None of them were paid. Some came back twice. 340 hours is an average of 7 hours per person, but in reality the distribution is uneven. Some volunteers spent 20 or more hours on the mudflats, returning in different seasons. Spurn Point in winter means wind off the North Sea, temperatures near zero, mud that drags at your feet. The bags are heavy and awkward. The window between tides is limited. These people did what no machine could have done more precisely. They placed each bag exactly where the mud and sand meet, at the right angle to the current. And now, a number worth noting. Oyster reefs support more than 466 species of marine organisms, identified and documented. Crabs, flounder, sea bass, mussels, tube worms, not one of them can exist where there is no reef. That is what those bags in the mud actually mean. Here's what 300,000 oysters means in numbers. One adult oyster filters up to 200 liters of seawater per day. 300,000 oysters, 60 billion liters per year. 16 billion gallons, for anyone more comfortable with American units. The water moving across these mudflats no longer passes through a void. But the Humber remains one of the filthiest estuaries in Britain. Agricultural runoff from the fields of the Trent and the Ouse, industrial residues, turbid silt. The oyster filters the water, but it also accumulates everything that water contains. If the water is chronically polluted, is a natural filter sufficient to save the system, or do the sources need to be removed first? This is what the skeptics have always seen clearly. The oyster amplifies what is already there. If what is already there is aggressive pollution, then oysters will slow the degradation, but will not stop it. To grasp the scale of this problem, consider Chesapeake Bay, the largest estuary in the United States. Oysters once filtered its entire volume in a matter of days. Today, after a century of overharvesting and industrial runoff, that takes more than a year. That is precisely what 30 years of restoration work in Chesapeake Bay has shown. Oysters clean the water around the reefs, but beyond them, the water remains the same. The Nature Conservancy, which is an official partner of Wilder Humber and simultaneously one of the leading forces in oyster restoration in Chesapeake Bay, looks at the Humber as a test of a method that can be scaled. But they know better than anyone, scaling a method and scaling a result are not the same thing. And now the part that does not appear in any press release. Ørsted conceived of Wilder Humber as a pilot. One project, one estuary, 5 years. But what is happening simultaneously in Scotland, Norfolk on the Thames is already a domino effect. The Oyster Restoration Company now has inquiries from 6 other British projects. The method that skeptics called the illusion of control is becoming the standard. And there is one more thing that nobody planned. Ørsted's wind turbines in the North Sea have themselves become artificial reefs. Their steel foundations have been colonized by mussels, sea anemones, sea urchins, and tube worms. Researchers from Leiden University published findings in 2023. The number of benthic invertebrate species in the zone around turbine foundations is twice as high, and the number of individual organisms is 100 times greater than on the open sandy seabed nearby. A company accused of disrupting the marine environment has inadvertently become its builder. This complicates the picture. The greatest lesson of the Humber is not whether 500,000 oysters will survive. They could survive and deliver zero benefit to the ecosystem if agricultural pollution remains. Or they could become a turning point if density proves sufficient for self-reproduction. Nobody knows the answer yet. That is honest. But here is what is known for certain. For 80 years, there was nothing in the Humber. Now there are 300,000 living oysters. Someone has started counting. The first real data goes back to 2019. That was when Yorkshire Wildlife Trust established test plots in aquarium cages at Spurn Point. The first 3,000 oysters survived. More than that, spat appeared on them, new larvae that had settled entirely on their own. But why did this resolve a question that had been debated since the 1990s? Because nobody had known whether oyster reproduction was possible at all in the water of the Humber, not whether they would survive. Survival can be ensured artificially. The question was, is the water clean enough for larvae to settle on their own? That is a different threshold entirely. When the spat appeared, small juveniles no larger than a coin, with no intervention whatsoever, it meant one thing. The natural cycle in the Humber was still possible. The water is turbid, murky, laden with agricultural runoff, but the larvae found their way. That was the answer that could not be verified without a live experiment. Wilder Humber launched in 2022, not coincidentally 3 years after that spat. And the program is not yet finished. It runs until 2028. The next steps are already defined. First, a comparison of survival rates between rapid reefs and the traditional method. If the difference proves significant, the method will become the recommended standard for all British projects. Second, seagrass. Alongside the oysters, the project is restoring Zostera marina, the other major filter feeder and fish nursery. Initial results from the 2023 to 2024 plantings show partial establishment. This is a separate scientific strand that will determine whether the reef becomes part of a broader ecosystem or remains an isolated island. Third, if 500,000 oysters reach the threshold of self-reproduction, Yorkshire Wildlife Trust and Ørsted are discussing the possibility of a second phase, expansion into the subtidal zone below the low water line. Conditions are more stable there, but costs are higher and monitoring is more complex. The question that nobody has yet answered, Will wilder Humber become a model or remain a single example? One company with one pilot does not save a species. It proves that something is possible. But possibility and scale are not the same thing.